Okay, I'll just go on a little bit more. Just a little bit of background on ACAMP then. We were established in June 2008, so we've been going on for about a year. We're really just getting up and running, and we've already engaged with quite a few potential companies working in the clean tech space. We have $15 million of funding for 5 years, which is split roughly into 2 parts. The first part is operational funding. It's pretty important for us to keep cranking the employing people and running projects, so we have some operational funding that's going to keep us going. This is supplemented by fees that we charge our customers as well. And we have capital funding, which is enable us to buy a bunch of equipment which we can use for product development, including assembly and packaging, but we're also very strong on product characterization as well. And we'd like to talk to the guys from Nint about some of their activities, so I think we can dovetail in there as well. Perhaps the unique thing about us that makes us a little bit of experiment compared to many similar centres set up around the world is that we're pretty much independent from academia and government. We're able to operate in a commercial manner. And the senior management team, myself and Ken and some of the other guys, all have at least 20 years of experience in relevant industries, and our managing board is in fact really led by local finance and industrial communities. So although we're government funded, we're very strongly industry led and industrially oriented. We're easy to work with as well. We have a pretty simple fee for service model. We recognise that we have to buy our equipment, so we'd like to recoup some of the cost of the purchase of the equipment through a depreciation model. We charge out our manpower. We're not for profit, so we don't try to make profit on anything we do. We charge our manpower at cost, and we expect our clients to pay for materials and consumables that get consumed in the projects. But because we're very much in product development mode, the actual consumption of materials and consumables is pretty low in the project, so that's not a big burden for the clients. We have one other big benefit for local clients. We're based in Western Canada, and that includes, I think, Manitoba, Saskatchewan, Alberta, and British Columbia. And all those, because we're funded quite heavily by the Western Canadian government, or at least through the Western Economic Diversification Fund, we offer some very attractive discounts to Western Canada companies, so they don't have to bear even all the cost of this stuff, so we can make our interactions very attractive. We're also pretty flexible in terms of engagement models. We're very commercial guys, so we'll do what it takes to help people. So clients can come in, they can rent equipment, use our engineering expertise, ask us to manufacture them, and of course we can run business development projects for them as well, help them identify gaps in their business and strengthen their business case. We don't expect to retain any IP. That's the client's product IP is their IP. They're there to develop it and free to use it, of course, once they finish working with us, which sets us aside from most consultancy models where they try and take a stake in the IP. We do, however, like to retain some know-how that we develop on processes, because we like to be able to share that around the entire Western Canada community, and we believe that that's where we make our unique contribution in developing and retaining process know-how. So we have 2 major streams of activity. Roughly half the team, we have 20 people on board now, and roughly half the team is involved in business development. And what we typically find is many clients come in and they don't have a very focused idea of the market, and they want to go for exactly what the product they're going to develop is, what the specification is going to be. So actually most of the people we work with at the minute are going through the process of sharpening up their ideas, producing business cases, and working with our business development team. We use a pretty sort of standard sort of business development sort of 101 methodologies to do that. The other half of the team is the team that I'm responsible for, so I'm more likely to talk about this, is the product development side. And here we're really working on the sort of classic product development methodologies again to help people turn their ideas into products. We don't do any front-end fabrication, as I've already explained. That's very well represented in the region. But we do a lot of work on assembly and packaging and product test. And we are very strong on inline test and characterization, design for manufacturability, and a lot of simulation and design as well to make sure that we enable people to develop high-performing products. So, just to say a little bit more about what we do then in the product development area, one of the key things we've had to do is focus down a bit. I mean, when you talk about product development in the micro and nanotechnology space, that's a huge, broad base of technologies, and in fact, we can't really do everything. We have identified 2 major areas, and this is why I'm talking about one of them is microfluidics, and that's really why I'd like to talk about that today. We believe there is a tremendous opportunity for that in a variety of the key target markets across Alberta. The cleantech is certainly one, healthcare is another one, and we think even agriculture and forestry as well. So we think there's some tremendous opportunities for microfluidics, and we're setting ourselves up to be able to implement a polymer-based microfluidic technology. Polymer is important because of the low cost and disposability aspects. Essentially, if you try to do the same thing in hard materials, they tend to be more expensive, and it's very hard to make disposable chips which meet the cost targets. Of course, it's not that we can't design and work with hard materials if you need to for non-disposable microfluidic applications, but That's not where we're going just at the moment. We also have a little activity I'll just briefly refer to in being able to make complex ceramic modules. This is really being used in the oil industry for improving the efficiency of oil production by creating downwell instrumentation. So we're quite pleased about that activity as well, and that's a contribution to Greentech. So if you do choose to work with us on a product development project, we have quite extensive product development facilities, 200 square meters of clean rooms in Edmonton, and in fact another 100 square meters of clean rooms in a satellite facility in Calgary, which should be opening up in about a month's time. In fact, perhaps a little bit sooner than that. And the clean rooms in Edmonton enable us to do all the different activities such as hybrid module assembly and packaging and microforming that let us create those complex microfluidic modules. We also have an extensive test and characterization area as well, and we think that's an important part of product development. Coming from a product development background, I like to know what I'm making when I'm making it. And we have quite extensive design and simulation tools as well, so we can really make sure we do a really good job of designing the product before we commit to spending money on manufacturing. Microfluidics capabilities, I think it's probably worth talking about those a little bit. I guess our key tool that is arriving pretty soon is our hot embosser, and this is a tool for enabling us to microstructure polymer substrates to create the microfluidic channels. And once we get it up and running, it's going to be a very powerful tool. There is already an R&D tool in existence in the University of Alberta at NanoFab, and we're working quite closely with those guys at the minute to do a couple of research projects that we can then transfer to pilot production. We have some other interesting tools coming along as well. I think perhaps I highlight the laser drilling and cutting tool, which is going to be very useful for doing all sorts of odd shapes and forming structures. And we have access to a bunch of other equipment as well through our network of regional partners, and we're constantly expanding that network as well to enable our customers to have the widest possible base on which to design their technologies. Simulation and design, I mentioned ANSYS Multiphysics. It's one of probably our leading finite element solver. It has an excellent fluidics model in it, although listening to the previous talk, I can see ways to improve that fluidics model already, so I'm going to be quite keen to have a go at that sometime. We do some solid modeling we can do in order to input into the multiphysics, and we have some other design tools for doing electronic design work as well. Just to mention the hybrid module characteristics, we have some interesting things such as screen printers, which can be very useful for creating microelectrodes in microfluidic channels. I think that's being used by a number of different companies, and we can do things like punching holes in plastic using high-speed punches, and sticking layers together and plating various exotic metals to create electrodes as well. So quite a broad range of capabilities for microfluidics, and then precision assembly and packaging as well if we need it. So, characterization capabilities, I'll just leave that slide up there. I think I'm running out of time because Daryl's getting itchy here. So just to summarize then very briefly, I believe that there's a tremendous opportunity for microfluidics and lab on a chip in Cleantech, and we're already starting to see some projects coming through, and I expect to see a lot more. We've been set up to help companies in Western Canada to commercialize their product ideas as best we can, and you've got a whole bunch of useful facilities for developing microfluidic products and technology platforms. Thank you very much. Okay, I'll ask myself, are there any questions? Just one quick one, perhaps. Hello.
Who is behind ACAMP? Who are the people which formed this company?
It's essentially funded by by both Western Economic Diversification and the provincial government.
The government?
Yeah.
Okay.
But we are led by, we have been given money as a bunch of industrialists to go ahead and commercialize technologies.
How do you get a hold of you? Do you have an address or?
Yes, we certainly do have a contact address. I didn't put it on the slides, unfortunately, but I'll give you my card afterwards. And yeah, we're just in fact based in the research park, just a few hundred yards from here, so easy to get hold of. And in fact, you can look at us on the web as well, www.acamp.ca. All our contact details are there as well. And if you see any of the girls on the front desk, I'm sure they can give you our contact details.
Thanks.
Thanks.